Hi, I'm Nico. In this video, I'm going to talk about the 4 kinds of iron allotropes: alpha, gamma, delta, and epsilon. Now, you may be wondering, where is beta iron? In the past, beta iron referred to the iron above the Curie temperature but below the temperature at which iron becomes gamma iron. The Curie temperature, by the way, is the temperature at which iron loses its magnetism. However, later analysis revealed that the crystal structures of alpha and beta iron are identical, and since then the term beta iron has no longer been used. Today, what used to be called beta iron is classified as alpha iron. The phase transition from alpha iron to gamma iron occurs at approximately 910 degrees Celsius. Here, its crystal structure changes from body-centered cubic to face-centered cubic. In gamma iron, carbon can take up to 2% of the mass, while the maximum solubility of carbon in alpha iron is only 0.02%. This is because the sizes of each gap in a face-centered cubic lattice is larger than in a body-centered cubic lattice. This property is useful when you want to make steels with different properties. The third allotrope, delta iron, forms when gamma iron is heated above about 1390 degrees Celsius. Here, the crystal structure of iron goes back to a body-centered cubic. I wonder how the properties of gamma and alpha iron are different because they both have a body-centered cubic structure. Let's move on to the last one, at least at the time of recording. Epsilon iron, also known as hexaferrum, forms when alpha iron undergoes a phase transition under high pressure. Epsilon iron has great significance in the field of geology because it is thought that some of the iron in the Earth's core might exist as hexaferrum. I've never thought that iron also had allotropes. I wonder what proportion of existing substances undergo structural phase transitions.